All right, guys, so now we are on section 2.1. And I'm going to solve some problem on page 57. And I'm going to start with the problem number 13. So if you look at the problem number 13, what do we have? They're asking you to find the measure of the indicated angle, and they are giving you a, let me do that, not too bad for doing that with a ruler. And so we're having FC, we know that the angle right here is 50 degrees. And so we have D, B, E, and A, and we need to look for the angle AOB. So first of all, we need to define where is my angle AOB, and my angle AOB is right here. That is my angle AOB. So that is the angle that I'm looking for. So right away, what I can see is my angle AOB is made of the angle AOE plus the angle EOB. When you look at the angle AOE, we have right here a right angle, meaning it's a 90 degree, and the angle EOB is an angle that is equal to 50 degrees, because if I have 50 degrees, and I'm going to change my color and take a green, if I have 50 degrees right here, I will have 50 degrees right there. And so total for my angle, it's going to be 140 degrees. Let's try to do another problem, and let's try to do problem number 19. In this problem number 19, what do we have? We have to calculate the angle correspondent to the angle number 1. And for that, we have, so let me take a ruler for this one. You have one like this, one like that. I'm getting, there we go. And I am having technically a 90-degree angle going this way. And so I have, knowing that this is the angle, this angle is 62 degrees, that is A, B, let me get rid of the ruler, B, C, and D. Where is D? D is right here. We have the point of intersection. This one is 2. This one is 5. Then we have the angle 1. Right there we have 4. We have 3 right here. We have 6 over there. And we know that we have a right angle right there. So if I'm looking at the angle 1, what I'm looking for is for the angle right here, and this angle number 1 is equal to 62 degrees. Okay? Now, I would like to remind you that we called, rather in the problem number 13 or problem number 19, we call these angles the vertical angles. So I would like to repeat that. In these two problems, we had to deal with vertical angles. All right? Okay, now let's continue and let's try to do problem number 25. In the problem number 25, we are dealing with what? Find the measures of the angle in the truss shown in figure 214. So I'm going to show you, and I'm going to draw this problem number 214, and forgive me if I'm not using my ruler. And actually, I'm going to make a pause, and I will be back with you as soon as it will be done. All right, guys. So I just made the figures 214, and the first thing I want to do is right away notice that I have a 90-degree angle right here. I got a 90-degree angle right there. I got another 90-degree with right there. And then I can also try to remember a few things in terms of angles. First of all, because DE is parallel to AC, the angle FDE will be equal to the angle FAC. Equal to the angle FAC. And I know that the angle FAC equals 44 degrees, so I can literally say that my angle FDE equals 44 degrees. So I know that I can totally write right here, this is 44 degrees. I can also see an angle right there, 90 degrees. All right, very well. Okay, so now what is the question? The question is, I would like to remind you, find the angle BDF. So I need to, the question is, find the angle BDF. So where is this angle BDF? My angle BDF, and I'm going to use another BDF. This is the angle BDF. And I can see clearly that this angle BDF is made of the angle BDE plus FDE. BDE plus the angle EDF. And so if I look at that, I end up to have BDE, it's 90 degrees, plus EDF is 44 degrees, and so I end up to have an angle equal to 134 degrees. All right, so on the problem number 29, the question was to find the angle DFE on this figure that I draw just right here. And the angle DFE, first of all, the triangle DEF is a right triangle with an angle EDF equal 44 degrees and an angle DEF equal 90 degrees. So I know that in a right triangle, the sum of the three angles is equal to 180 degrees. So therefore, I'm able to express the angle that I'm looking for as the subtraction between 180 degrees minus 134, corresponding to the sum of the two other angle. And so I end up to have 46 degrees. Problem number C, problem number 33. And the problem number 33, it's about finding the distance C in the figure 215. I'll let you look at this figure 215 by yourself. And how do we find this distance? So to find C, what we are going to do, it's absolutely very simple. We are going to look at the segments of transversal, and we are going to say that C divided by 3.2 will be equal to 5.05 divided by 4.75. Now you want to have C by itself, so you will have to multiply the left side by 3.2 to have the 3.2 divide out, and so you will have to multiply by 3.2 the right side. So now C is equal to 3.2 multiply by 5.05 over 4.75. And the answer is going to be 3.4. Why did I decide to use 3.2 meter and 4.75 meter? Because if I was using the other transversal 3.05, I could not use A because A is a variable that I don't know the value, and so I will have one equation with two variable. Let me show you that you could have wrote is C over 3.05 equal 5.05 divided by A. And if you decide to do that, you end up to have one equation, two variables. And that is not possible. It is not possible for you to find the C with only one equation. You need to have another equation. It was much more easier to use the other transversal. All right, so now let's move on to the problem number. And which problem did I decide to give you? Problem number 43. All right, let's move on to problem number 43. On this problem number 43, what do we have? All right, so in this question, problem number 43, the question is to find the angle BCD. So the question is to find this angle right here. All right, so what do we do if I want to find this angle? It's very, very simple. First of all, what I want to look at is the understanding the notion of supplementary angle and complementary angle. And I would like to remind you that a supplementary angle, by definition, is when if the sum of the measure of the two angles is 180 degrees, then the angles are called supplementary angle. Why do I want to focus on the supplementary angle? And to aside, what I could have is something like this. All right? The sum of these two angles, this angle right here, and this angle right there, the sum of these two angles is equal to 180 degrees. And because the sum of these two angles, so if I call the angle A and right there the angle B, A plus the angle B is equal to 180 degrees. Well, in that case, we will call A and B supplementary angle. All right, so that said, why I want to focus on supplementary angle? Because obviously, if I have 47 degrees right here, that means I will have 47 degrees right there. And so now, if I'm looking for the angle BCF, my angle BCF is going to be equal to 180 minus 47 degrees, which gives me a 133 degree. Right, guys, so it's very, very important that you are writing your note properly by making sure that you know the definition of what is a vertex, what is a point, what is a line, what is a plane, what is a supplementary angle, what is a complementary angle, but also what do we call an adjacent angle or a vertical angle. This is a lot of definition that you must know perfectly well, otherwise you will be in trouble. All right, so thank you very much, and I will go to another section right now.